Now coming in the next one is your work. Now work here, it's not the mechanical work, I've clarified earlier only. It is the physical work or the chemical work we can say. When you are taking a gas, it is better to say chemical work. Now, what is work basically? The formula we require, work is nothing but the force into displacement. We can say that. Clear? So here, what we'll do, using that particular concept only, we'll move forward. Let us say I have taken a container. Here it's a container. Alright? And it's a closed container, of course. Some gas is present inside the container. Clear? Now, the cross-sectional area of this container, the cross-sectional area, this is your cross-sectional area, we can say that, of the container, which is nothing but is your small a. The cross-sectional area of the container is your small a. Got it? Now, some gas is present inside the container, we can say that. So, you are exerting some pressure. The gas is going to get compressed. You are applying some pressure. The gas is going to get compressed. Now, how will you apply the pressure? Let us say that I have kept a metal plate here. Alright? And this is a piston. I am taking it. This is a piston. And I am putting some weight upon this particular piston. I am putting some weight. That means I am applying some external pressure. Some external pressure I am applying to it. And this external pressure is applied in this direction. The external pressure, you can say that. So this is your P external. Let me write it very clearly. So it is P external. So when I apply some external pressure, slightly, it's not a huge pressure I'm going to apply. A small pressure I'm going to apply. Alright, then what will happen is that this is going to come down slightly. It is going to come down slightly. Alright. Or I can do it in other way also. That is, I have kept some, that the previous experiment, I'll keep some weight here or some sand here, and I will take out some sand particles from here. So what you will find is that there is some internal pressure is there. So as a result, instead of the gas compressing, the gas is going to get expanded. Have you understood what I said? Now when I am applying some pressure here, the gas is going to get compressed because here the piston is going to come here. Let us say somewhere here the piston is going to come from here. So there is a small change in length which is called as a DL. The small change in length is there, that is known as a DL. Got it? The piston was here. By applying some pressure, by putting some weight, the piston, it comes down a little bit, slowly, little bit. And there is a small change in length, that is known as the DL. DL is a small change in length, we can say that. It was here, it comes here. It can be in other way also. In other way, here the external pressure is more than the internal pressure, so the gas is getting compressed. As the external pressure is more than the internal pressure, the gas is getting compressed. Suppose the internal pressure is more than the external pressure. I am applying an internal pressure which is more than the external pressure. If P internal is greater than P external, internal pressure, how it will be greater? Let us say instead of putting some weight, I will put some sand here. So just like in the previous experiment, I was explaining the reversal and the irreversible process. So what will I do? I will take out few particles of sand from here. So when I take out few particles of sand, the external pressure is going to decrease and the internal pressure will be more. And the gas, instead of getting compressed, the gas will get expanded. It will go up. Means initially it is here and it will also move up. What is the change in length? It is same DL. Let us say the small change in length which is taking place is nothing but DL. Alright, so hence when the external pressure will be more than the internal pressure, the gas is going to get compressed. The gas is going to get compressed. This is the work done upon the system. You are doing the work, no? This is the work done upon the system. Listen. Now, when the internal pressure be more than the external pressure, then the gas will not get compressed. If this pressure is more than this, then the gas will expand slightly. I said, initially the piston is here, it is going to rise here when the internal pressure is more than the external. I am taking, in case of internal, I am taking this is initial and this is the final. The gas is expanding. So here the work is done by the system. System is what? The gas which is present inside the container, the gas. That is the system. So when the external is more than the internal, again I repeat, the gas is compressed. This is the work done upon the system. When the internal is greater than the external, the gas is expanded slightly. Alright, then this is the work done by the system. So here, both the work are different. The work done upon the system and the work done by the system is different. How? That only we are going to tell you. Now, here, what you will find is that the pressure I have taken initially, I will consider this P external and I will derive it. I will consider this P external, I am going to derive it. That is, I am going to consider the work done upon the system and I am going to derive it. Alright, fine. So, now you know that is here P is equal to nothing but, what is that? Force per unit area. Alright, pressure is equal to force per unit area, or I can say force is equal to pressure into area, because pressure is equal to force per unit area. So force will be pressure into area. Area in this area, cross-sectional area. And this is the external pressure. External pressure, mind it, I am saying you. Now, next is what is work done? What is then work done? Work done. I said now, the work is done upon the system. So what is the work done? Work is nothing but force into dl. This one. Now what is force? Force is pressure into area into dl. Now what is A into dl? A into dl is nothing but dv. A small change in volume. So work done, what we got it? Nothing but PdV. PdV is also can be said to be as P delta V. Also we can say as P delta V. dV is small change in volume. Delta V, same thing is. So P delta V or PdV, whatever you consider that. So it is other words, I can say V2 minus V1. V2 is the final volume, V1 is the initial volume. V2 minus V1. Alright, so this is V1. This was your V1. Let me rub this. See here, this was your V1, the initial volume. Now, this is your V2, the final volume. We can say that, where the final volume is less than the initial volume. When the P external, I am going to consider. Alright, if I am considering the work done upon the system. If I am considering the work done by the system, then this will be your V1 and this will be your V2, where what you can say 1 will be less than V2. That is, the final volume will be more than the initial volume. Definitely, because expansion is taking place. Got it? When the work is done by the system. But when the work is done upon the system, then the compression is taking place. It is the gas is getting compressed. So ultimately what we got the formula? W is equal to P into V2 minus V1. We got this formula. Now here again I repeat, it is a P external, I am taking it. Fine. Now remember it. Now here one thing you have to take it. By convention, according to the SI convention. Alright, according to the SI convention, what we are doing is that W is taken to be positive if the work is done, that is upon the system. The work done is taken to be positive. It is considered to be positive. Again I repeat, according to SI convention. Alright, work done is considered to be positive if the work is done on the system. That is the compression, we can say that. Alright, it is a compression, the work is done upon the system. And if it is taken to be as negative, the work is done by the system. That is expansion, by the system. If the system is doing the work, if the gas is doing the work. Gas is doing the work means expansion. That is taken to be as negative. Again I repeat, work done upon the system, that is your compression upon the system, that is taken to be as positive. This is a convention I am taking. Again I repeat, convention. Convention means, for example, when you throw a body upward, in physics you have read it, G is negative. When the body comes downward, G is positive. Is in the body, is it written? Suppose this body I am throwing it upward, is it written in the body, the G negative when it goes up? And when it comes down, is it written in the body, G is positive? No, it's a convention I am taking it. I have to take a particular value. So I have taken the particular convention. That yes, when it goes up, it is against the gravity, it is negative. But when it comes down with the gravity, it is positive. It is a convention. For example, we say conventional electricity. It flows from positive to negative. Positive to negative, anything it flows? Nothing. Always electrons flows from negative to positive. So if that is electronic current, then what is from positive to negative? What is that current? Conventional current. We also call it as conventional current. So it is a convention. You have to consider it. Okay, I hope you understood. So in this way, what we find is that is work done upon the system is positive, work done by the system is negative. Got it? Now here also, that is the general expression for the work done is not written P V2 minus V1. It is written as minus P V2 minus V1. minus P V2 minus V1. This is again I am saying, it is a convention. Again and again I am saying you. It is according to the SI system, this expression is being taken, that W is equal to minus P V2 minus V1. And this is the work which I am saying you, the work done by irreversible process. This is an irreversible process, the work done by. Got it? When the external work I am saying, initially right from the beginning I am saying external work. So that is an irreversible process. Alright, and hence here it is a P external. It is irreversible process. So W is equal to minus P V2 minus V1. So here as you see, V2 is less than V1. You can see. And the work is done upon the system. V2 is less than V1. So V2 minus V1, if I do it, is negative. Delta V is negative. Here another negative is there. Negative from negative is positive. So hence work done upon the system is positive. I said it, work done upon the system is positive. Understood now? Here P means, let me write here very clearly, it is P external. I am talking to you about P external. Alright, I am talking to you about irreversible process. Mind it, this formula you will use it for irreversible process. Work done by an irreversible process, when it said you will be using this particular formula, minus PV2 minus V1. So when that is the work done is upon the system, I said the work done is positive. How it is positive? That only I am explaining you. Here it is, we got V2 minus V1. So when the work done is upon the system, you can see V2 is less than V1. This is the final volume. This is the initial volume. Compressed, the gases. So V2 is less than V1. So this is negative. Negative from negative is what? Positive. So hence the work done upon the system is positive. The reverse is in case of compression. Alright, in case of expansion, when the work is done by the system, what I said you, this will be your V1 and this will be your V2. So V2 will be greater than V1. So when V2 is greater than V1, the work V2 is greater than V1. Understood? In the other case, the work done by the system, I said it is negative. How it is negative? Because this will be your V1 and this will be your V2. At that time, I am not going to consider the external force. I am going to consider the internal pressure. Definitely, here it is. Because the work is done by the system. Why I am going to consider the external one? Internal only. Fine. So hence, in that case, what you will find is that minus P V2 minus V1, the formula is, this is a general expression for work done for an irreversible process. Fine. So here V2 is greater than V1, you can see very clearly, V2 is greater than V1. So V2 minus V1 will be positive. Here it is negative sign is there, minus into plus is minus. So work done by the system is negative. Alright, I hope you understood. That is the work. Again I repeat, this formula you will be using it for the work done by an irreversible process. So work done upon the system is positive and the work done by the system is negative. Alright, thank you.